Good morning. This is September the 28th, 2014. Woke up this morning. I walked outside to get the Sunday newspaper, and there was a bit of nip in the air. Well, not exactly a nip, but it was a lot more pleasant than we normally wake up to here in Texas. Usually it's still like the desert in the daytime. Okay. But now the weather's starting to cool, and it was a beautiful morning. I think we had 66 degrees. But that's not what I want to talk about. What I'd like to talk about this morning, earlier, let's say a couple of days ago, I sent my class a description of parallel resistances in a voice recorded message. And the voice recorded message was too long, so some of the students got it and some did not. So I've thrown together this conglomeration that I have here. I have a piece of an old lamp that's acting as a stand for my camera, and I don't have very good lighting. Now that I've made all excuses for the poor quality of this presentation, let me dive into the presentation. What I'm going to talk about this morning is parallel resistances. The class has studied this earlier, and they have a book just like I do, and what I'm going to do is point out some possible stumbling points that might be encountered in working these problems. And it's a lot easier once you understand that parallel resistances are actually real simple to work on a calculator. So let's go right into it now. Let's talk about parallel resistances. I'm on page 18. And I want to talk about the total resistance. Notice here that they have a resistor drawn that symbolizes total resistance. And they say that the total resistance here equals R1, R2, R3, and out to the nth resistor. Now what do we mean by the nth resistor? We're meaning it could be R4, 5, etc., and etc., being to the nth degree. Now, in order to understand or to properly calculate the value of RT, I have a formula. 1 over RT equals 1 over R1 plus 1 over R2 plus 1 over R3 to the nth. Okay? Now, let's look at an example. Let's put some numbers in there. If R1 equals 6 ohms and R2 equals 8 ohms, and R3 equals 12 ohms, and R4 equals 4 ohms, find RT. Well, I'm going to write this formula here that RT equals 1 over R1 plus 1 over R2 plus 1 over R3 plus 1 over R4. I hope you followed that. It's a fairly simple, straightforward problem. So let me go ahead and write that. Then I'm going to say that 1 over 6 plus 1 over 8, and I'm going to say plus 1 over 12, and then I'm going to say plus 1 over 4. And we want to take the reciprocal of that. Okay. Now, are we ready? Let's go ahead and use the TI-30XA calculator. In order to use that, the first thing I have to do is turn it on. And I notice that there's a previous problem in there, so I'm going to turn it off and clear it. Okay, now I'm at the start. In order to set up this calculator to work these problems, what we want to do is go into scientific notation. And in order to do that, we hit the second, which means we're going to be looking at the functions that are printed on the body of the calculator. Now, most of the students have this calculator, and as a consequence, they understand that there's, in gold print in most cases, there's the double the functions that you have on the keys. In this case, we're going to use scientific notation, which is located under the 5. Now, I hit that, and notice what I have now. I have 0, and I have 2 exponents of 0, 0. Now, here in this class, we want to work to an accuracy of 2 decimal points. So I hit the second once again, and now underneath this period it says fixed. What I'm going to do, I'm going to fix the decimal point at 2 places. So I hit that. I hit the point, which is actually the fix button, and then I hit the 2 for 2 decimal points. Now notice now that I have 0.000. The computer is now ready to start calculating the problems that we want to use in scientific notation. Now the first thing I need to do is look at the first resistor. It's a 1/6. It's a 6 ohm resistor. So I put in a 6, and then I hit 1/x, which is reciprocal. Then I hit plus. Now I'm going to do the 8 ohm resistor. So I put in an 8, and I hit the reciprocal, and then I hit a plus. Now I'm going to do the 12 ohm resistor. I punch in 12, and I hit the 1/x, and then I hit a plus. Now I'm going to do the 4 ohm resistor. I put in a 4, and I take the reciprocal of that, and then I hit equals. Now notice that now we have the combination of what's underneath on the denominator. Now the numerator, which is a 1, we're going to punch in and take the reciprocal of that. So up here I'm going to do the 1/x again. And notice what I come out with. I come out with 1.6 ohms. Now there's something unique about that. The uniqueness is this. The uniqueness is that in a parallel circuit, and that's what we have here, in a parallel circuit, the resistance of the total is going to be less than any resistor in the chain. Now let's look at that. Why would that be? Because we have a fraction, don't we? And when you're dividing a fraction, you're always going to be less than the whole. Now I'm going to put this on hold for a second, and I'm going to get a cup of coffee.